Trying to balance the scale. I'm adjusting the little knob on the end there, trying to get this lined up perfectly. And it looks like I overshot there. So let's cut back just a little bit. Alternatively, I could put something just on the balance in order to offset it. Let's see, that's too far, so out just a couple degrees. Looks pretty well lined up right there. All right, so before, with nothing on it, it is set. Everything is off to the left, so there's 0 grams as the initial reading. Now we will put the cup and the piece of tape on there. All right, so now put the styrofoam on the balance. And it's not going to be much. Now we don't have the thread on here because we are assuming that the mass of the thread is negligible, and that is something that you're going to make a judgment call on later. That's looking pretty darn spot on. All right, I have not adjusted the back two. Those are still on 0. So you should be able to get an estimated digit there. See if I can stabilize that. We need to know the length from the pivot point down to where the mass is, the hanging mass, sort of the center of that mass. So basically I'm going to take a meter stick, and you should be able to judge from there. So remember that the pivot point is at the hole there. Let's see if I can get the hole from this side. Yeah, because the hole is just below the metal bar. And that distance right there is from the desk. It is not from the mass itself. We're about to go to where the mass is. There is the mass, and you sort of use your best estimate about where the center of mass of this is. See if that gives a little bit better perspective. See, there's the hole, there's the bottom of the hole right there. That's where the so attach to that. And then trying to make sure that the string is dangling from that center hole right there from which the angles are measured. And you can see that when the string is just hanging there, the string is at that angle. I've got a little bit of parallax. I'm trying to standardize that. A little bit of swaying, but hopefully not enough to mess this up. Here's the LabQuest 2. I have it connected to a charge sensor, so if we look at the wire right here, working its way around, and this is the main box for the charge sensor. We have a gray button on this right-hand side, which is used for zeroing. So if I'm going to press that, and we can see what happens. So that's sort of the charge in there right now. I press it, and notice it drops really close to 0. There will be some charge creep, so it's not like I don't have to keep re-zeroing it. Therefore, I will keep re-zeroing it. Now, the sensor right here is hooked to this cable, and that is hooked to a split right here in the wire. So we have this red wire right here and this black wire. The black wire I have connected through, there's a wire right here connected up to the metal screw, which is then connected to the metal pole. I need some place to be a source of electrons, or of course a place to dump electrons. The other one, the red clip, is connected through wires to this sort of aluminum cup made from my pie pan. And so when I dip this, when it's charged, I'm going to dip it into the pie pan, and if this is positively charged, then it's going to draw electrons from there through the wire, and then charge sensor, and then to here. And so the charge sensor is going to know how much charge is flowing one way, or if this is negatively charged, it'll chase electrons back in the other direction. And so either way, it's measuring the charge that's either pulled onto this or pushed off of this. That's how it's actually measuring the charge, at least a little bit more detail. So let's find out how well this is actually going to work. What I'm going to do is I'm going to use this rabbit fur to charge this piece of styrofoam, and to charge this, we're going to find out the charge on both of them. Then I'm going to bring this closer to it. As I bring it closer to it, this should repel, which will change the angle up there, and then we'll be able to actually do some calculations based upon that. So what I'm going to do is I'm going to set the LabQuest 2 onto the graphing mode. I can look at the change in charge and be able to pull the beginning and ending charge from that, and from that I'll know what charge is on the item of which I'm measuring the charge. I've lowered the temperature of the house. I have a dehumidifier going, that's the noise in the background there. All trying to keep this dry. The more humid the room is, the faster the charge is going to leave this thing. So let's first get a sense of that. It's charged. Now potentially it could be losing a mess of charge as we speak. Let's get some sense here. So let me start that. Zero this. And then bring that in there. It looks relatively stable. This is the trial that I just did. We have some initial value over here. This is when I put it inside the aluminum and it drops off, and it's relatively stable right here, so we're not losing a whole lot. It doesn't seem particularly humid in here, or at least there's not a drastic change, which I've seen elsewhere. And this is when I removed the cup. It's still somewhat near it. I need to remember to take it farther away. And actually my presence can affect it as well, but considering the nature of this lab, probably not affecting it significantly, but we can always make that as an excuse if it doesn't work out perfectly. Let's get some measurements here. All right, so analyze statistics. All right, so it's finding the statistics for this range right here, the part that I've highlighted, and we have a maximum at negative 1.02 and a minimum of negative 1.85. Probably should have gone a little bit farther, so let's do that again. Analyze statistics. All right, so it's basically find the statistics for the shaded range there. So we have a charge, which is basically the difference between those two. When I took it out, let's just see what that looks like. So now we're doing a different range, and the minimum here, or the maximum, is negative 1.39. That should be somewhere around here, as opposed to over here, which was 1.0 something. But we have more than a nanocoulomb of charge. Recognize that these units are in nanocoulombs, just as is listed right there. All right, so I haven't recharged the cup, so this is just with the charge that's being read. It doesn't necessarily mean that's the actual charge on it. Foam cup hanging there, and there is the initial angle. Only so much I can do to stop the breeze there. And in terms of placement on the meter stick, if you sort of follow that string straight down, where does that fall on the meter stick? All right, so putting this edge here. All right, so hopefully that string is straight down. Where does that string lie on it? So that's So that's 10 centimeters right there. This is somewhere around the 20 centimeter mark, and that'd be 30 centimeters right there. So sort of do your best estimate based upon the cup about where that string actually lies. It should be somewhere around the 20 centimeter mark, but it won't be exact. The more retentive you are, the better it will be in the end. All right, so should be something like that. There, that's the spot right there. Charging up the PVC, PVC in, and still maxing out. So PVC out, discharge, PVC in, PVC out, and I'm going to zero that baby and try that one again. PVC in, PVC out, PVC in, PVC out, PVC in, PVC out, zero it, PVC in, PVC out. Charging up the styrofoam. Styrofoam in, styrofoam out. Time for the angle. Putting that so that it's centered over the 15 centimeter mark, and we have an angle. And we have an angle. Charging PVC. In. Out. Let me zero it. In. Out. They're turned to about the same level, so I'm good with that. Charging the styrofoam. Styrofoam in. Styrofoam out. Styrofoam in. Styrofoam out. Wow. Styrofoam in. Styrofoam in. Styrofoam out. Styrofoam in. Styrofoam out. That's looking like about the same level. Bringing PVC near it. making sure, and PVC's in place, that angle. All right, so recording, this is what I believe is going to be trial 3. Charging up the PVC. And I'll discharge some, so let's zero it. Oh, lost some there too. There, that's about the same amount, so we will call that good. Charging up the styrofoam. Styrofoam in and out and in and out. And that looks like it's about the same height, so we are good to go there. Now bring it into the angle with the PVC pipe at the 15 centimeter mark and even with it. And that's the angle there. Trial 4, PVC, PVC in, obviously too much. There you go, that's about the same. Charging up styrofoam, styrofoam in, styrofoam out, styrofoam in, styrofoam out. And that's looking close enough. Putting the tube at the 15 centimeter mark and even with, so basically putting it at the 15 centimeter mark, the middle of it, the 15 centimeter mark, and then even with the styrofoam, and we get an angle. There. In and zero it. In, out, almost, in, out. We're going to call that close enough to the same height. Charging the styrofoam. In, out, in, out, in, out. And that's looking relatively constant. Putting the PVC pipe at the 15 centimeter mark. Raising it up. Angle. Charging PVC. PVC in. Let's zero that again. PVC in. PVC out. Zero it one more time. PVC in. PVC out. Yep. All right. Charging styrofoam. Styrofoam in. Styrofoam out. Styrofoam in. Styrofoam out. And that's looking like it's about the same. Bring in the PVC. Make sure that's lined up so that's I'm in the right spot. PVC at the 15 centimeter mark, up level, and we have angle.